Hello, this is the first of probably 5 videos for section 6.4 for Monday, March 16 in Math 220 Calculus. Today we are going to be dealing with something called implicit differentiation. Implicit differentiation is the solution to the question, how do we differentiate functions that cannot be easily solved for y? Up to this point in the course, all we have taken derivatives of are functions already solved for y. But now we will start taking a look at more complicated looking functions themselves. So we are going to differentiate implicitly. We will also find lines tangent to implicit functions at specific points, and then work on some applications. So basically what we're going to do for implicit differentiation is use all the rules that we have learned so far for finding derivatives, and we're going to apply them to functions that contain x and y that can't be easily solved for y. So we're going to differentiate on both sides of the equation with respect to x. We will take d by dx. When an equation contains an x, that's nice. When a portion or a term contains an x, that's nice. When a term contains a y, when we differentiate y with respect to x, we get the quotient dy dx. So what we'll have is this new equation with probably at least one dy dx's in it. We solved for that dy dx, and that is what the derivative of y with respect to x is. Recall that a derivative is essentially a slope at a point, and the definition of slope from way back in high school algebra was the change in y over the change in x, which is precisely what dy dx actually is. So we'll start with a couple of more straightforward examples before we start getting into problems that take a little bit more time to work out, starting with question 2 on page 353. Here we have 7x squared minus 4y squared equals 24. This could technically be solved easily for y, but we're going to practice finding derivatives with implicit differentiation for equations that are easier first to practice, and then we'll get to more complicated examples. So 6.4.2. 7x squared minus 4y squared equals 24. We will differentiate both sides with respect to x. And this is nice and easy. The derivative of 7x squared with respect to x is 14x. The derivative of minus 4y squared with respect to x is minus 8y dy dx. The derivative of 24 with respect to x is 0. Next, we isolate the term containing dy dx. So that will give us 8y dy dx equals 14x. I've added 8y dy dx to both sides and then swapped sides. Next, we divide by 8y on both sides. Dy dx then is 14x divided by 8y. Next, we reduce this fraction to show that dy dx is 7x over 4y. Typically, with implicit differentiation, the dy dx is a quotient, typically. And sometimes, as we will find shortly, they get complicated quite quickly.